discuss about Stp testing. So in this we have this Stp testing here, spanning tree testing. So in spanning tree testing, we'll discuss about we are just taking these 4 cases for now. Again, I'm saying there are more concepts. If you'll go and study more concepts, you can add more. But I'm just taking very basic concept and I'm showing the test case done. So, root bridge election based on lowest bridge ID. Root port will be lowest cost port. So, root bridge election as we discussed already. So, who will be the root bridge? It will depend on lowest bridge ID. Similarly, root port will be lowest cost port. DP should be best port for segment. So first of all, we will start with the root bridge. So you can write in a more descriptive way, verify that root bridge, the bridge who is having lowest bridge ID will become root bridge. So we'll use the topology here. So now the switches are in the block state, they are showing orange. So we'll just wait for this to converge. And by default STP is enabled. You need not to configure anything. By default into switches STP is configured. So in the theory section we have discussed, when you have redundant path means a backup path. So here you have one path from PC0 to PC1 and there is other path from PC0 to PC1 via switch 2. So you can reach to PC1 in 2 ways. One is via switch 0 to switch 1 to PC1, other way is switch 0 to switch 2 to switch 1. So in such environment there will be a chance of broadcast storm which will make lot of issues. So for that we have STP, spanning tree protocol. So what we'll do, redundant path will be disabled, and when the main path goes down, redundant path will come up automatically. So here this is our main path and this was the redundant path. So we have made one port blocking so that we will not have a redundant path active all the time. We will activate only when this main link goes down. So what we have to verify now here in this STP configuration or an STP setup, that first thing, root bridge, we have to verify that the one who is having lowest bridge ID is becoming root bridge. So how you will verify? Just go to CLI and check. First of all, we are into user mode. We have to go to privilege mode or enable mode. Now so this is the CLI command to check. So here you can see root bridge ID is 3276. So bridge ID consists of 2 things, priority and bridge ID and MAC address. So priority is 32769, address is this one 0007. So there is a MAC address. So this together will make our bridge ID. So this bridge ID will decide who is the root bridge. So that we have to verify what is written in the theory, is it following the same thing or not. Like lowest bridge ID should be our root bridge. So here it is. You can see here also this bridge is the root. So in the bridge we have logged in, that is only our root bridge. So what is the, we'll open other switch as well and then we'll compare. This was a switch 0, now switch 1 will open and we'll give the same command here. So here you can see priority is same. Here also priority is same. So when priority is same, it will be looked for MAC address. So who is having lowest MAC address, that will become our root bridge. So that should be our root bridge. That is what expected. So here you can see 0007 and the switch 2 in the starting, 0007 in the starting, all are having 007. So we'll see ECC4 here also, ECC4 here also. So here 2AC2, it's 2A, sorry, we were checking for the wrong thing. We have to check for the bridge ID. So bridge ID is E000E0. Here it is 00650 and here it is 007. So we can see switch 0 is having lowest bridge ID and priority. So this is simple case. Like what we have studied, at lowest bridge ID should be selected as root bridge. So that is what happening here. Okay, now you can add one more case. Here is like after changing the priority, what happens? It will change the priority to a lower value. Suppose we have these three switches. One switch priority we have reduced it from 32768 to 4096. What will happen? Then the one who is having lower priority, it should become root bridge. So that kind of cases also you can add. So now root port will be lowest cost port. So, and you can add one more case here is like root bridge will not have add root port. So in theory part we have discussed root bridge will not have root port. So that also we can verify here. So these are small cases. So the thing is like whatever theory things we'll know, we have to check it by using test case. So more test cases you will have, more things you will check, and your software will be more stable. So will not have root port. That also will check. We'll go here. You can see we have in this switch 0 is our root port. How we can analyze that? See, it is written here. This bridge is the root. This was 0. So now here you can see designated port is there, designated port is there, designated port is there. So all 3 ports are designated port. So there is no root port available. If we'll go to switch 2, switch 1, designated port, root port, designated port. Okay, so you got one more case. See, alternate port and root port. So only non-root bridge will have root ports. Now next case was root port will be lowest cost port, so that will verify. So switch 0 we need not to, we have only in switch 1 and switch 2, means this is our root port, switch 0 is our root port. So switch 1 and switch 2 will have root ports. Switch 0 is root bridge, so will not have root port here. So switch 1 and switch 2 will have root port. So we have to ensure that lowest cost path port will have root port, will be root port. So here in switch 2 we have 2 ports, FA0/2 and FA0/1. If you see, FA0/2 is giving us, we have a direct link to reach here, and every port, every link is having same speed or same cost. You can say 19 here and 19 plus 19 here. So here it is reaching with 32. With this port, if you want to reach to root, it will be 19 plus 19, 38. But if you want to reach from here, it will be 19. So now it will be our this port FA0/2 should be our root bridge. If that is the case, we'll say case is passed, else case is failed. So you can see here 0/2 is our root. So this is expected and it is passing. Okay, now we'll see to a switch 2, and here also we are expected to get the lowest port, lowest path cost port to be root port. So 0/1 and 0/2. 0/1 and 0/2. So when we will see 0/1 and 0/2, again 0/1 is giving us 38 path cost and 0/2 is giving us 19 path cost. 0/2 should be our root port. You can see 0/2 is our root port. So this is one more case we have. We can tell it as this path. Now similarly DP means designated port should be best port for segment. So for one segment, for every segment there will be one designated port. If you'll see here, In the diagram, you have three different segments. One segment is this, one segment is this, one segment is this. So every segment will have one designated port. So in this, we have one in this link which is connected to root bridge. We have already this as designated port. We have checked it already. So switch connected the port which is directly connected to the root will give the best path, will be the lowest path cost to the root bridge because it is directly connected. So for this segment we have three segments, one segment, second segment, third segment. So for this segment, FA0/1 will be the least cost path to the switch 0. For this segment, switch 0's FA0/2 will give least cost path. For these two segments, designated port is decided and it should be 0/1, 0/2. It is understood, but here it is a problem. You will see here for this link, for every segment there should be one designated port and one designated port. So here the condition is from this interface, if you want to reach to root port, it will take 19 cost. And here also it is taking cost as 19. So now there is a tie. In the tie condition, what it will do, it will check for the sender bridge ID. So sender bridge ID is lower in case of switch 1. So switch 1 who is having lower bridge ID, that will become, that will get more priority. So this will become designated port. So this is how we have to check and finalize. We can say that things are passed. Now we'll see on failure of DP block port should come up. So then finally we got to know designated port and root port and everything. So we decided like one port should be blocking. This port is blocked. Now this redundant link will not work. We cannot use this path to reach from PC0 to PC1. So we have only one path. Now what we want to do, suppose this link goes down, what is expected, this link should come up. So we are making it down and seeing what happens. So now we are checking this, we were discussing about failure condition. So if suppose one side root port connectivity goes, so this is our root switch, and suppose the 0/2 goes down, means the main path has gone down. So redundant path should expected to come up. So this is the one which is blocking port, should come to forwarding state. That is what expected. So let's see whether it is happening or not. It should go green. So it should take some 30 seconds. Okay, so you can see here now this main path has gone down, this high cost path has gone down, so we have the redundant path came up, everything you can see green. So now you can say this failure condition, so one main path has gone down, so redundant path has come up. So what we can say, on failure of DP block port should come up. So this case we can say it has worked fine. So likewise you can add multiple cases as well, like you can add several more ports, and you can check for direct failure and indirect failure kind of cases, and you can add multiple links also between the switches, and you can try to uh, implement this HTTP and see what kind of things are happening, and then you can add test cases related to those things as well. So more and more concept you are knowing, try to add more and more cases. That will uncover more uh, problems into the software, and it will try to make your software more accurate. Thank you. And in next section we'll discuss about this layer 3 protocol like OSPF and